For this question we need to graph the sequence an equals a quarter times 3 to the n minus 1. So what I'm going to do is start with thinking about as in if it was a graph, because there is a huge difference between a sequence and a function, and it's the domain. So what I'm going to do, I'm going to think about, well, what if f of x equals 3 to the power x? So we'll take this and we'll build it up into something that looks like a quarter times 3 to the x minus 1, x n minus 1. So if you had something like that, you should know that 3 to the power 0 is 1, so it passes through at 1 there. 3 to the power of 1 is 3, so it's going to go sort of through 1, 3, it's maybe there. And then anything beyond that, 3 to the power, say anything more than 1 is going to get bigger. And then state 3 to the power, so 3 squared is 9, so it's going to go through 2, 9, 3 cubed is 27. It's going to get really, really steep really, really quickly, just like that. And then the other way, well, 3 to the power minus 1, say, is going to be minus a third. And then it's 3 to the power minus 2 minus a ninth, 3 to the power minus 3 minus 1 over 27. They're really, really small numbers. It's never going to go to 0. It has an asymptote here. So it does something like that. Didn't quite want it to go that far, but never mind. So that's y equals 3 to the power x. So if I wanted f of x equals 3 to the power x minus 1, sorry, if I wanted 3 to the power x minus 1, well, that would be the same as f of x minus 1, which hopefully you know that is a horizontal translation. So it's a translation of the original 3 to the x graph by 1 unit. So it's going to go, everything's going to go one place to the right. So that point is going to be there, and this point is going to be here, and so on. And it's going to end up sort of looking something like that. Now, if I say had times this thing by a quarter, so a quarter f of x minus 1 must be a quarter times 3 to the x minus 1. Now, if you have this effect of timesing by a quarter outside a bracket, it's a vertical transformation because it's outside the bracket, it's a stretch because it's a multiplier, and because it's outside the bracket it does exactly what you'd think. So from this function it's a vertical stretch, scale factor 1 over 4. So basically all of these distances from the invariant line, the x-axis, are going to be quartered. So this distance here, if I kind of split it, it's going to be about there, that point. If I take this point here, it's going to be probably somewhere around there, and so on. This point's probably going to be something like that. So it's going to be a lot flatter, but it's still going to do the same sort of thing, like that. Okay, now that's the graph of y equals a quarter times 3 to the x minus 1. Now, we have been asked to graph the sequence an equals a quarter times 3 to the n minus 1. Now, the difference between a sequence and a graph is that the domain of n, the domain is, well, basically n needs to be a positive integer only, because if you think about what the n is, it's the term number. So the n can be 1, 2, 3, 4, 5. It's the term number. It goes up in intervals of 1, and you can't have a 0, and you don't have a 0 term, and you certainly don't have negatives. So as far as graphing the sequence, it's going to follow this line, but it's only going to have certain values. So it's going to have, it's going to do things like this. So your basic graph, and I'm going to attempt to draw it, its first value is going to be sort of at 1 and a quarter, so 1 across a quarter up, and it's just going to gradually sort of get bigger a bit, kind of like that. And it's going to start to rise, something like that. I'm not going to put exact values in, but that would be the graph. So that might be a of n compared to n. If you wanted to work those values out, of course you could do it. You could just substitute in for n. But that's the basic idea, and this just keeps going. Intervals of 1. So 1, 2, 3, 4, 5, 6.